6. And as you maybe can tell by looking at the problem, we're going to get to practice factoring some more. So you may or may not have gotten to factoring on your pie chart, but if not, we got more practice. So we're going to simplify some fractions. In order to simplify our fractions, we have to have them in factored form so that we can reduce out our common factors. So if I look at the top part of this first one, first thing I want to look for, is there a greatest common factor, something I can divide out of all the terms so that my numbers aren't so big. In this case, I can divide both of these by 4. So I'm going to take the 4 out first to reduce it down a little bit so that my other factoring is a little easier. If I divide 4 out of that first term, it's going to leave me just the u squared. If I divide 100 by 4, it's going to leave me 25. Then I'm going to look at what's in the parentheses and say, can I factor that farther? Hopefully you recognize that's the difference of perfect squares, and yes, I can factor that using my conjugates. And so I'm going to have 2 sets of parentheses, factors of u squared, u and u. Since this is a negative, we know we're going to have 1 plus and 1 minus, and then factors of 25, 5 and 5, right? So I've got the top as factored as much as I possibly can. I'm going to look at the bottom. On the bottom, there's not a greatest common factor that I can divide out of all 3 of my terms. And so I'm just going to go to the FOILing thing. So I'm going to jump way over here to this part, since I don't have a greatest common factor, and I'm going to factor that. Factors of u squared, u and u. The end is a positive. That means both signs are going to be the same as the middle, a negative and a negative. And then since this is one with a leading coefficient of 1, the factors of 15 that add up to 8. 5 and 3, right? So that if I did negative 3u plus negative 5u, I got that negative 8u in the middle, right? The outside plus the inside adds up to the middle. Now what should happen is you should at least have one pair of common factors. Here it's the u minus 5. I'm going to be able to cancel those out of there. So on the top I have 4 times u plus 5. On the bottom I just have the u minus 3. Don't really need the parentheses on the bottom since it's not multiplied by anything. So we'll get lots of practicing, factoring, and factoring some more. So, number 2. If I look at that one, if I look at the top, not a greatest common factor, especially I can tell because there's a u squared and there's not a number in front of my u squared. So I'm going to go to that last step, so I'm going to jump way to the end here. And so we want to factor out u squared plus 2u minus 24. So the factors of u squared. U and u, right? Then I want to figure out my signs. The end sign is a negative, so I know my signs are positive and negative, one of each. Positive times a negative gives me a negative. I want the factors of 24, that when I do the outside plus the inside, it's going to add up to a positive 2. So think about all your factors of 24 and how you could plug them in so that if one's a plus and one's a minus, they add up to positive 2.
Two and 12. Oh.
Now if I do 2 and 12, they're going to be too far apart, right?
Okay.
Does that give me 10?
Oh.
It's another pair of factors for 24.
12.
We already did 2 and 12. We said that was too far apart.
12, no?
Well, 12 and 12 wouldn't be 24. Factors. What times what is 24?
Okay,
what times what is 24?
6 and 4.
6 and 4. So if I want to get a positive 2, that means the bigger number has to be by the plus sign, right? 6 minus, whoops, it doesn't like that there. 6 minus 4 is 2, right? Negative 4u plus
Okay.
6u is the 2u in the middle. Exactly. Now, if we look at the bottom, that one does have a greatest common factor. I can divide all of those by
I'd say 4.
I'd say 4 too, yep. All of those are divisible by 4.
I've just been wrong.
So I'm going to divide them all by 4 first. So 4u squared, if I take the 4 out of there, I just get a u squared. Negative 4, if I take the 4 out of there, I get a negative u. And then negative 48 divided by 4 would give me negative 12. I'm then going to factor that part a second time. That 4 is still in front, and then my 2 sets of parentheses because I'm going to FOIL out what's left in the parentheses. So, factors of u squared. U and u. Looking at my signs. Again, the end is negative, which means I know what for my signs?
A positive and a negative.
Positive and a negative. And now I want the factors of 12 that when I plug them in, I get a minus 1u in the middle, right? A minus u is a minus 1u.
So you just want to minus u?
Yep, you just want a minus u. But you know that you have a plus and a minus, so you're going to subtract your values and end up with a minus 1. So what pair of factors of 12 would only be 1 apart?
3 and 4.
3 and 4. Since I want to have a minus, the bigger number has to be by the minus.
Okay.
So I'm going to have a 4 here and a 3 here. Negative 4u plus 3u. Negative 4 plus 3 is negative 1. Now we can see, hey, we got a common factor of u minus 4. We're going to cross those off of there. So on the top, we have u plus 6. On the bottom, 4 times u plus 3. Hope you guys are writing smaller than I am. I have these in Word now. Next time I can add more space, so when I write really big, I'll have more room. All right, I'm going to erase this here, and I'm going to have you go ahead and see if you can get started on number 3 there. Look to see if you have a greatest common factor first. And if you do, factor that out. So on the top part of that fraction, do you have a greatest common factor? You can factor out all 3 of those terms?
4.
4. And if I divide 4 out of there, what am I left with?
12u. Oh, u2.
U squared
U squared.
minus
3.
3u minus
4.
4, exactly. Then we have to factor again. So, factoring the u squared minus 3u minus 4. Factors of u squared.
U
U and u. My signs.
plus and negative.
Plus and a negative, because again we got a negative on the end. And factors of 4 that give us a minus 3 in the middle.
3 and 4.
Factors
Oh.
of 4.
Factors of 4.
What times what is 4?
Oh, 2.
Now if I do 2 and 2, what am I going to get in the middle? I'm going to get nothing, right? Because plus 2 and minus 2 is 0. What's the other way to get 4?
1.
1 and 4. Which one has to be by the minus sign?
4.
The 4, because it's bigger, and we want a minus 3. So negative 4 plus 1 is the minus 3 in the middle, right?
Yep.
All right. Bottom one doesn't have the greatest common factor. Go ahead and try to factor that one out. So we know u squared is u and u. The next thing you want to think about is what is your signs going to be? The end is positive, so both signs are the same as the middle. They're both going to be negative, right? A negative times a negative gives you that positive on the end, but will add up to the negative in the middle. So now we're thinking about the factors of 12, that when I plug them in, I'm going to get 7. What times what is 12? 3 and 4. When I put a 3 and a 4 in there, I'm going to have negative 4u plus negative 3u, which adds up to negative 7u. And we knew one of them had to match up. In this case, it's the u minus 4 that we can cancel out of there. And so our answer, 4 times u plus 1 over u minus 3. Alrighty, the next ones we're going to simplify just by reducing them. We'll get to some more factoring ones in a little bit. But here, we're just simplifying our fractions, and when we multiply fractions, we can cancel out the common factors. I like to just start with my numbers, my coefficients first to see if I can reduce them, because sometimes there's variables I need to combine, and if I do try to cancel at the beginning, sometimes I miss stuff. So I like to just go ahead and say, okay, I can reduce the 7 with the 14. The 7 goes into there once, into the 14 2 times. Then I'm going to go ahead and multiply the top together. 2 times 2 is 4. I have a b to the 5th. And then I have a c times another c, so I'm going to have c to the 2nd power. On the bottom, I don't really need the 1. I'm going to switch the order around because I like them alphabetically. So I'm going to write the b squared first and the c to the 3rd on the end, just so everything lines up nice. Not that you have to do that, but then I'm going to cancel with my variables. We said when we're reducing those, we're going to subtract the lower one from the bigger one. So I have a b to the 5th on the top and a b squared on the bottom. I'm going to get rid of the b squared, which is going to take 2 off of my 5 and make that b to the 3rd power, right? On my c's, I've got 2 on the top, 3 on the bottom. I'm going to subtract off the lower one, which is the 2 from the top. 3 minus 2 gives me 1, so I just have a plain old c on the bottom. So what I have left is 4b to the 3rd on top and a plain old c on the bottom.
I was going to say, how'd you get the 4? But I see what you did, okay.
The 2 times the 2 up there on top, yep. So number 5, if I first simplify my coefficients, I can reduce the 2 with the 4 and the 5 with the 15, right? So 2 goes into 2 once and into 4 2 times. 5 goes into 5 once, into 15 3 times. So multiplying across the top, 1 times 3 is 3. I have a b to the 5th. And then I have a y times a y squared. Y times y squared, y to the 3rd, exactly. So 3b to the 5th y cubed on top. On the bottom, 1 times 2 is 2. I got a plain b and a plain y, so by. And then I'm going to reduce those variables down. How many b's can I take out of there?
1.
Just 1. Leaves me b to the 4th up on top. How many y's can I take out of there? Just 1. Leaves me y to the 2nd up on top. And so I have 3b to the 4th y squared over just a 2. All right, go ahead, try number 6. Well, that one's numbers aren't so big. That one might be a little easier. So you started out and you did some canceling. 2 goes into 2 once and into 6 3 times. 5 went into 5 once and into 10 2 times, right? So on the top, 1 times 2 is 2, and then you have an A and an X. I like them alphabetically, but if you put XA, it's the same thing. On the bottom, 1 times 3 is 3, and then you're going to have an A, and you have an X times an X, so you get X squared, right? Canceling. Well, I'm going to cancel out my A's altogether because there's 1 on the top and 1 on the bottom, so the A's will be gone. I'm going to take out one of my X's, and so I have an extra 1 down on the bottom, so 2 over 3X should be my answer. We get that? All right, good. 7, 8, and 9, back to doing some factoring again. You can see that there's those squared things in there, and whenever you have those quadratic expressions, we know we're going to end up factoring. So what we want to do is try to factor the tops and the bottoms of our fractions as much as possible. Sometimes we can't do anything to them. X minus 1 doesn't have any greatest common factors, doesn't have any squared terms, so I just have to leave that as X minus 1. I'm just going to rewrite it over here. I'm going to put it in parentheses to remind myself, oh, yep, that goes together. If I do the bottom of the first fraction, the bottom of the first fraction has the squared. We know we can FOIL those out. So 2 sets of parentheses, factors of x squared, x and an x. The end is a negative, so we know we have a plus and a minus. And then we want the factors of 6 that give us that minus 1 in the middle. What pair of factors for 6 can we use?
2 and 3.
2 and 3. We want the 2 to be positive and the 3 to be negative because we want the bigger one to be negative since we want a minus 1 in the middle. Then we go to the top of the next fraction. Now on the top of the next fraction, it has 2 terms, but I noticed, oh, it has a greatest common factor. I can divide the 4 out of there right away. So I'm going to factor the 4 out. 4x divided by 4 would leave me just an x. 8 divided by 4 would give me a 2. So 4 times x plus 2 is how I'm going to factor that. On the bottom, doesn't have a greatest common factor, doesn't have a squared, I can't do anything with it. It's just going to stay x minus 2 then. Again, I could put it in parentheses just to remind myself that goes together. So in this case, when I look to cancel, there's only one pair of factors I'm going to be able to cancel. There's an x plus 2 on the top and an x plus 2 on the bottom. I can get rid of that pair of factors, but that's all I'm going to be able to cancel out on this one. When I write my answer, it's x minus 1 times 4, but we know we usually like the 4 in front. It looks prettier there. So they're going to write it as 4 times x minus 1 on the top. The bottom, the order doesn't matter. You have an x minus 3 and an x minus 2. And if you put the 4 behind the parentheses, it's the same thing. It just looks weird back there.
What's the bottom gonna be?
The x
Oh,
minus
okay.
3 and the x minus 2 that we didn't cancel out. I'll move the board up so you can see better on the next one there.
X minus 3.
So number 8, we're going to start with the top of our fraction. It does have the squared, so we know we can FOIL that out. Factors of x squared would be x and x. My signs, since the end is positive, they're both the same as the middle, and the middle's a minus, so we know it's a minus and a minus. Factors of 2, that add up to the 3 in the middle. Well, 2 only has one pair of factors. 1 times 2. That happens to add up to 3, right? We got the top factored. We got to factor the bottom. On the bottom, there's only 2 terms. Tells me look for the greatest common factor. In this case, they're both divisible by 3, right? So I'm going to take the 3 out of each of those. 3x divided by 3 is just a plain x. 3 divided by 3 is 1. So we get x plus 1. Top on my second fraction. Only 2 terms. Doesn't have a greatest common factor. I'm just going to leave that one alone. It's going to stay x plus 1, but I'm going to write it in the parentheses because it has to be grouped together. Bottom of the second fraction. Squared. I know I got my 2 sets of parentheses. Factors of x squared, x and x. My signs, positive and a negative. Factors of 6, so I end up with a plus 1 in the middle.
Two and 3.
And which one has to go by the plus sign?
2.
I want a plus 1.
Oh, 3.
The 3, the bigger one, has to go by the plus sign, right? Positive 3 minus 2 is the plus 1 in the middle. So the other one, we had a minus 1 in the middle, and so they're just switched around. Looking to see what we can cancel. What can we cancel on this one?
The x1, x plus 1.
The x plus 1s. Anything else?
The x minus 2.
The x minus 2s, exactly. So on the top, the only thing I have left is that x minus 1. I don't need the parentheses since it's not going to be times anything else. On the bottom, we have this 3 here, and then we have the x plus 3 over there. So we get x minus 1 over 3 times x plus 3. All right, go ahead, try number 9. So on that first fraction, what did you do with that first fraction?
Just left the top alone.
Left the top alone as x plus 1.
3.
And took a 3 out of the bottom. So you got 3 times
X minus 1.
x minus 1, exactly. Next one you had to FOIL out. We know it's an x and an x. Our signs would have been
Positive and negative.
positive and negative because the end is negative. And we want the factors of 2 that when we plug them in, we get a positive 1 in the middle.
2 and 1.
2 and 1. The bigger number has to be by the plus sign. Positive 2 minus 1 is plus 1 in the middle. On the bottom, we know we had to FOIL that one out. And again, we have x and x. Our signs, one of each because the end is negative, right? So positive and a negative. Factors of 3 that when we plug them in, we get a minus 2 in the middle.
1 and 2, or 1 and 3.
1 and 3, and which one has to be by the negative side?
3.
1 and 3. We knew the middle one to be negative, so the bigger number had to be by the negative. So, what can we cancel out of there? X plus 1, x minus 1. And that looks like about it. So our answer, x plus 2 over 3 times x minus 3.
That's way too much thinking.
We're only in the review. All right, the next one's hopefully back to a little bit easier thing. Trying to remind you that with fractions, if you're dividing, you're going to flip that second fraction and then multiply. So I'm going to rewrite my problem. 9b over 2a. First fraction stayed the same. Going to change it to multiplying, and then I have to do the reciprocal, so the 8ab goes on top, and the 3b to the third goes on the bottom. Now I do it like those multiplying ones. So I'm going to start with my coefficients and do some reducing. 3 goes into 3 once and into 9 3 times. 2 goes into 2 once and into 8 4 times. So if I multiply the top together, 3 times 4 is 12. I have an A, and then I have a B and another B, so B to the second power. On the bottom, 1 times 1 is 1. I don't really need that. I have an A and a B to the third. And then I'm going to do some canceling. The A's cancel out altogether. I can take 2 of my B's, which leaves an extra 1 on the bottom. And so I'm just going to get 12 over B. So number 11, same thing. I'm dividing fractions, so I'm going to rewrite it as a multiplying. 9b to the third c to the fourth over 4c times the reciprocal, 2c over 3b. So, reducing my coefficients. 3 goes into 3 once and into 9 3 times. 2 goes into 2 once and into 4 2 times. So if I multiply across the top, I'm going to get what?
3b, 3c, 5.
Exactly. 4 plus 1 more is 5. On the bottom,
2bc.
2bc. And then I'm going to do some canceling with my variables. I can take out 1b and 1c. And so my answer is going to be 3b squared c to the 4th over
2.
just a plain old 2, exactly. All right, go ahead and try number 12. So you started out and you wrote the reciprocal of your second fraction. So you had 6y to the 4th over x to the 5th y times 5x to the 3rd over 8y. Reducing, what can you reduce there? You can reduce something.
Oh shoot, the 6 and the 8.
The 6 and the 8 are both divisible by 2, right?
A's. Now my answer's all wrong.
You can always reduce that 2 out at the end if you recognize that, oh, I can reduce by 2 at the end. So if you forget to do it at the beginning but you get to the end and you forgot to reduce it down then. Because if I had 30 over 8, those are still both divisible by 2. So I reduced right away. I'm going to get 15 x to the 3rd and y to the 4th. And on the bottom, I'm going to have a 4, and then I'm going to have an x to the 5th and a y to the 2nd. So reducing that down, I can take out 3 of my x's, which leaves me x squared on the bottom, and I can take out 2 of my y's, which leaves me a y squared on top. So 15y squared on top and 4x squared on the bottom. Should be my answer.
We should do more of those.
Do more of those?
Instead of the factory stuff.
Oh, guess what? We get to do more of the factory stuff.
The stick break, right?
Good. Right. Well, we're almost to the end. We've got a few more there, but we're almost done with the factoring stuff anyway, at least on this page. So, dividing fractions again. Our first thing we want to do is flip that second fraction. So the first one's going to stay x squared minus 1 over x squared plus x minus 6. But then we're going to multiply by the reciprocal, so the 3x plus 9 goes on top, the x minus 1 goes on the bottom. Then we're going to do it just like we did the multiplying ones. Start by factoring. Now, hopefully you recognize when you look at the top of that first fraction, it has the squared term. That's the difference of perfect squares. It only has 2 terms. So 2 sets of parentheses, x and an x. The end is negative, so a plus and a minus. And the only factors of 1 are 1 and 1. We get a negative 1x and a positive 1x, which is the 0 x's that we have in the middle. On the bottom, we factored those ones with 6's a lot. X and an x. The end is negative, plus and a minus. Factors of 6 that give me the positive 1 in the middle. plus 3 and a minus 2, right? 3 minus 2 is positive 1. Top of the next fraction. I hopefully recognize I have a greatest common factor of 3 that I'm going to divide out of each of those. 3x divided by 3 is a plain x. 9 divided by 3 is 3. Bottom doesn't have a squared, doesn't have a greatest common factor. I'm just going to leave that one alone as my x minus 1. And then I'm going to cross off my common factors. So I have a common factor of x minus 1. I have a common factor of x plus 3.
X plus 3. Oh, I forgot. Number. Okay.
And so on the top, we're going to have 3 times x plus 1. On the bottom, just an x minus 2. I'm going to write it up there so I have room for the next one. So number 14, same thing. We're going to divide fractions, so we've got to flip that second one over. So x squared minus 4 over 4x plus 4 times the reciprocal x plus 1 over x squared plus x minus 2. Factoring that top one. It's got the squared term. Came from foiling. How do we factor x squared minus 4?
4.
We're going to start
With
with
the x.
x and an x. My signs, negative and a positive, one of each. And factors of 4,
2 and 2.
2 and 2, exactly. Difference of perfect squares has to end up being conjugates, same terms with opposite signs. Bottom of the first fraction. What can I do at the bottom of that first fraction?
You can do the same thing.
I can do the same
you
thing.
did to the top.
Nope.
Oh, you can't?
Nope, because it doesn't have a squared. And if it doesn't have a squared, it's not going to factor into 2 sets of parentheses. But I can take out a 4, right? They both have a 4 in common. So I'm going to factor it like I did this one up here. The 4 is going to go in front. Now if I divide a 4 out of each of those, 4x divided by 4 is just x plus 4 divided by 4 is 1. So 4 times x is 4x and 4 times 1 is 4, right? Top of the next fraction. Doesn't have a squared, doesn't have a greatest common factor. Got to leave it alone. X plus 1. Bottom, that has a squared. We know it's going to use the 2 sets of parentheses, right? So x and x, my signs. Since this is a negative, 1 of each, plus and a minus, factors of 2.
1 and 2.
1 and 2, and which one is going to go by the plus sign since I want a plus x in the middle?
2.
The 2 is. So the plus 2 and a minus 1. Now I can do some canceling. I got a pair of x plus 2's I can cancel, and I got a pair of x plus 1's I can cancel, right? So on the top, we have x minus 2. On the bottom, we have 4 times x minus 1. All right, go ahead, try number 15, because I know how much you like to do factoring. So you started out, you rewrote that second one by multiplying by the reciprocal, and then we started to factor, right? So on the top of the first one, we have an x and an x. Our signs, positive and a negative. And we want the factors of 3 that are going to give us a positive 2.
2 and 1.
The factors of 3. We got to factor the n number. 3 and 1, right? So I want the 3 by the plus sign. 3 minus 1 is the plus 2 in the middle. So the bottom looks really close to the top, it's just that middle sign is different, right? So that should give us a big hint on factoring. We're going to have an x and an x, a plus and a minus, but this time we're going to put them in as 1 and 3, right? We want the plus 1 and the minus 3 to get a minus 2 in the middle. Top of that next fraction. What can I do at the top of that next fraction?
Well, you flip it.
I
So it's
flipped it
gonna
up.
be
3x plus 3 on the top. What do I do to factor the 3x plus 3? Do what, Joel?
X plus 1.
Take out the 3, so you have 3 times x plus 1, right? They both have a 3 in common. So 3x divided by 3 is x, and 3 divided by 3 is 1. So whenever I have 2 terms, but there's not a squared term, look for the greatest common factor. On the bottom, it doesn't have a squared term, and it doesn't have a greatest common factor, so we just have to leave that one alone. So now what can we cancel out of there?
x plus 3,
The x plus 3s,
x plus 1,
the x plus 1s, so our answer is going to be
3x minus 1,
3 times x minus 1
x minus 3.
over x minus 3. All right. Least common multiple. When I think of multiples, I'm thinking of bigger numbers. It's like you find your common denominator. So multiples of 2, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and so forth. Multiples of 10, 10, 20, 30, 40. What I like to do with my numbers with the least common multiple is start with the bigger one, which is 10. Does 2 divide into 10? Yes, it does, so that is my least common multiple. If it didn't, I'd do the next multiple of 10. So we know 10 is the least common multiple of 2 and 10. With our variables, we're going to use every variable to the higher exponent. Factors, we use the smaller one. Multiples, we use the bigger one. So, I have a u to the fourth and I have a u. Well, u to the fourth is the bigger one. I have an x to the ninth and an x to the fifth. X to the ninth is the bigger one. I don't have any w's here, but I have a w to the fourth here. 4 is bigger than 0. So I'm going to have 10 u to the fourth, x to the ninth, and w to the fourth. Again, the order of your variables really doesn't matter. You can do them in whatever order you want to put them down. So number 17, if I'm thinking about my least common multiple of 6 and 8, maybe you know it off the top of your head, but here's what I'm thinking. I'm going to start with the bigger number 8. Does 6 go into 8? Nope, it doesn't. So then I'm going to take 8 times 2 and say 16. Does 6 go into 16? No, it doesn't. So then I'm going to do 8 times 3, 24. Does 6 divide into 24? Yes, it does. So the least common multiple of 6 and 8 is 24. Then I'm going to do my variables. Each variable to the higher exponent. So with my v's, what should I have? V to the 8th. With my w's,
W9.
w9, and with my y's,
6.
y to the 6th.
6.
So 24 v to the 8th, w to the 9th, and y to the 6th is my answer. Go ahead and do number 18. So what is my least common multiple of 2 and 3?
I put 6.
That's what I put too. Exactly. If I had 1/2 plus 1/3, I'd change them to 6. So 6, and then what am I going to have?
U4.
U4,
W5.
W5,
V6.
V to the 6th. So 6u to the 4th, w to the 5th, and v to the 6th would be my least common multiple. So you're going to have two questions that look pretty similar. One will say find the greatest common factor, where we're looking for smaller things. The next one says find the least common multiple, where I'm looking for bigger things.
I didn't even read that.
Next ones, we're adding rational expressions that already have a common denominator. If I have a common denominator, I'm really just working with the numerators. So what I'm going to do is I'm going to rewrite this as one great big fraction and put all the rest up on top, but I'm going to put parentheses around my numerators. So I have a minus sign, 6a minus 10x, and then I have a minus sign, 8a plus 7x. And I'm really just going to work with my numerators. In this case, I have to get rid of the parentheses, so I have to distribute those negative signs out. So, here, negative and a positive is going to give me negative 6a. Here, negative and a negative is going to change that to a positive 10x. here, negative and a positive, going to be negative 8a. And here, negative and a positive, going to be negative 7x. Still all over that 8a, which is my common denominator. So if there's a negative sign in front, basically just changes my signs. Then I'm going to combine my like terms. I can combine my a's together, I can combine my x's together. I'm not changing any signs, I'm just putting them together. Negative 6 minus 8 is negative 14. 10 minus 7, positive 3. Tells me to simplify my fraction. The only way I can simplify it is if all three terms can be reduced by the same thing. In this case, I can't reduce all three of them, so that is my answer. You need to be careful when you type these in. This negative is on top of the fraction, not out in front. So make sure you hit the fraction button first and then type the top in separately from the bottom. If you do the negative sign and then hit the fraction, it's going to end up in front and not on top. So be really careful when you type those in that it ends up with the negative up there on top with the 14. So, rewriting this one all over my 5a. I've got a minus sign, and then I have 4a minus 2 in parentheses, because that's all on top of my first fraction. And then on this one, I've got a plus sign, and 8a minus 7b is going to be in my parentheses. So, distributing that negative. Negative times a positive. Going to give me negative 4a. Negative times a negative, going to give me a positive 2b, right? This one has a plus sign in front, so it's not going to change any signs, but I'm thinking positive times a positive is still positive 8a. Positive times a negative is still negative 7b. All over my 5a. And then I'm going to combine my like terms. Negative 4 plus 8 is positive 4a, so 4a. Positive 2 minus 7, negative 5b, right? Got to take the sign of the larger, over 5a. Again, I can't simplify this because all three of them would have to be divisible by the same thing, so I'm done. 4a minus 5b over 5a is my answer. Go ahead, try number 21. So first I just wrote it, parentheses around the first one, there wasn't any sign in front, minus sign, and then parentheses around the second one. So when I get rid of my parentheses, Nothing's going to change on the first part. There's really a plus 1 in front, but we don't need it. So that's still going to stay 8c minus 11d. On my second one, that has a minus sign in front. Negative times a positive is going to make that negative 6c. Negative times a negative, going to make that a positive 6d. On the bottom, we have our 4c. Combining my like terms, 8c minus 6c would be 2c. Negative 11 plus 6 is going to be negative 5d over my 4c. Again, I can't simplify that fraction, so I'm just going to leave it like that. Now, if I would happen to end up with something like 8x plus 12y over 4x, there would be something I could simplify, right? All of these are divisible by 4. I'm not going to do anything with the variables because the variables aren't all the same, but I could reduce all my numbers by 4. So this would be 2, this would be 3, and that would just cancel out. And so I get 2x plus 3y over x when I simplified it. But that's the only way you can simplify it, is if all 3 of them are divisible by the same thing. All right. That took a long time. I knew it would.